Okay, so in terms of the Altair part, and it's actually mostly just about and how do you have multiple charts in a single view. So in a sense, it's not critical. So for example, for the coursework, you can easily do with just single charts, which is completely fine. But if you want to, and you probably have to look at the examples in the lecture slides, and I don't have time to go through the details today. But essentially, I think even you don't use these compound charts, you are fine. And so the compound here just means you have multiple charts in a view. And in a way, it's similar to the dashboard, and you have and in Tableau. And many of you did your coursework without doing any dashboard, which is completely fine. It's similar here. For the next coursework, you don't have to use dashboard. Okay, and so the first concept is called the layered chart. Okay, so the idea here is you have multiple charts, but you put one on top of another. So you don't have multiple views, but you have multiple charts. Okay. So in this case, and we have two charts, I believe. Encode transformer. And so one is the actual line, and the other one is the circles on top. Okay, and the key here is use the plus signs to create the layer, the chart. Okay, so that's this line here. And so up to here, is all the same as before. So we import Altair, and this is, and I think we use that before as well. When you need to set some conditions, you need data, and this imports the data. In this time, we're using the stock data, and this is similar to what we did before. So we said we'll create a chart using stock and data and encoding. X is the time, Y is the price, and the color represents the symbol. And okay, this is the part we talked about before in terms of doing filtering. And we choose, say, the symbol equal to GOG. So that's the stock price, and GOG actually stands for Google. So you're only showing the Google price. And here is where the layering comes in, or you have basically creating two charts. And usually you would have the mark line somewhere here. You would say dot chart stocks, and then dot mark line, and then dot encode the blah, 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 like this. And here we'll put it below. So we had the base dot mark line, which creates this line, and then also base mark point, and which marks the data points, these circles. Okay. And so this is called layered because you essentially doing two graphs, one use a line mark and the other one use a point mark. They are drawn on top of each other, not two separate charts. So that's the layered chart. Okay, so this is another way. And so instead of using the plus sign here, you can say alt.layer base.mark line, base.mark point, or base.mark ruler. Okay, so this one essentially add another layer to the chart or a third chart, which gives you these vertical lines. Okay, and finally you add dot interactive. And so that's a function which will make it possible to zoom and pan the chart. So we didn't have time to, we did something similar last time, and by binding it to the axis, by binding the interaction to the axis. And so this is the equivalent, but this is like the shorter way to do this using dot interactive. Okay. Okay. And in terms of the ordering, because we have multiple layers, and so the one in front, layer 1, will be drawn first, and the one afterwards will be drawn on top of layer 1. So layer 2 will always be visible, and it might cover some of the layer 1. If, for example, layer 1 is more important, then you probably want to draw layer 2 first and then draw layer 1. So layer 1 is always visible, and part of the layer 2 might be covered if it's in front. Okay, and again, very quickly, so import things we need. We're using the movie data set, and the first one, and it's called a heat map, which is these like a colored blocks you see, and the white, green, and blue one. So go back. Still waiting to go back. No. Okay. And this part is quite similar to the one we did before. And we say that what data we're going to use, and the mark here going to be rectangle, which is a shape, and then do the encoding. So what is the X, what is the Y, and what is the color, etc. And so actually you can see here, we are doing a histogram. So you set the bin equal to true, and this color, and it's mapped to the count of points within each square or rectangle. But all these we covered before. And then this is a second chart. And here the mark is circle. So each point is represented the circle. Color equal to black. So okay, these are the setting of the mark. So for the circles, it will be black and size will be 5. And then the x-axis will be the rating, and the y-axis will be a different rating. So what the first one is from IMDb, the second one is rotten tomatoes. So that creates, this part creates a second chart, and that's the first chart. And then you join these two together. So you can see, and this is called heat map, which is heat map here. And this one is points, which is points here. And then you use a plus. So that joins these two together. So you can see, because the points is drawn afterwards, points is after the heat map. And so the points will be on top of the heat map, or these colored rectangles. And if you swap the order, the heat map is likely to cover the dots, which means you can't really see them. Yeah, and so that's exactly shows what I meant. So if we change the order, if we do the points first and followed by the heat map, and the heat map will cover most of the points, only then a few that will be still visible. Okay, and the next we're going to talk about, again, so multiple views, creating dashboard. Now the view is not, or the charts are not drawn on one on top of the other, and they're going to put side to side. And the first one, these are going to put next to each other horizontally. So you have two charts. You have this chart here and this chart here. This is one view of one Altair chart, and you have two views. They are side to side, and this is called an horizontal. So concatenation just means put them together, and horizontal means they're going to be side by side. Okay, and the function will be the h concat. So h stands for horizontal, and concat stands for concatenation. So that's the function for it. The short one will be, say, this vertical line. And this is the equivalent of the plus sign for the layers. So this is just a vertical line. Okay, and so we import Altair and the data set. We're going to using ARIS data. And then the first chart, and it's a point chart, essentially a scatter plot. And the second chart will be a bar chart. You can see marker is a bar, and zeta setup. And then finally, when you put these two, join them together and set side by side, use just this horizontal bar. That's all you need to do. And then you get this. And so this will be chart 1 on the left, and this will be chart 2, which is on the right. So that should be quite easy to do. And alternatively, instead of using this, so basically instead of writing this line of code, change, no, not change. And you can write, say, Altair.h_concat and followed by the charts that will be next to each other. Okay, and then this is actually quite similar. So previously we have the chart, which is one next to the other, and this one called vertical. So one will be the on top of the other. And so the function name will be v concat. So v for vertical and concat for concatenation. So the same. And again, the shorthand would be using the and sign. Okay. And this is again very similar. We imported the Altair and the data set, and then we select the source. In this case, will be SP500, which again is stock price. And this is for the interaction. So we covered that last week. Okay, then now we're having the two charts. And the first one is an area chart. Upper base.encoding. So this is still encoding, changing the encoding of this part, adding the interaction. And then the lower one. I see. And the lower one is a different chart, but it's both based on the so-called base. Yeah. Okay. But so usually you define two charts, and you say, in this case, we have the upper and lower. And then you say out.vconcat, and then these two will be draw one on top of the other. So this will be the upper, and this will be the lower. And you can also say upper and lower. Does exactly the same thing as this one. Okay. Yeah. Okay. And finally, it's called the repeated chart. And so again, this is just more like a convenience, something you can do without this and manually as well. What it does is sometimes you have these pictures, you have a dashboard, has multiple charts. These charts are actually all very similar. So for example, they are all and scatter plot. The only difference is the X and Y axis, and they'll be a little bit different, or maybe the data set used. So there's only small variance between these. And you could manually do this. You can say, I create this chart first, and I do a horizontal concatenation. So I put these two side to side, and I could create this one again, and then use another horizontal concatenation. So these two are next to each other. And finally, I'm going to use a vertical concatenation. So I put this one, these two charts together on top of these together. Okay. And so that's possible, just say with the horizontal and vertical concatenation. But they created something called a repeated chart. And to make this much easier, so you have to write less code to achieve the same effects. Okay, and so we import Altair, we import the data set, or as before, we're going to using the iris data set. So this is the base chart. So this is the part you probably should understand by now. So it's a point, and the color maps to the species. So that's the different type of flowers, I think, in the data set, and set the width and height. and make this interactive so user can zoom and pan. Okay, and so this is the part where you actually, sorry, this is the part actually you actually repeat. Okay, so first you say for y, the y-axis will be either pedal length or pedal width. Okay, and then the row it says out and h. Concord. So okay, I missed a little bit. So first, and you do this one. You say vertical concatenate, and then so the top one, sorry, I think this is the bottom one, is pedal length, and the top one will be pedal width. So if you look at next chart, so pedal width will be the one at the bottom. Okay, anyway, so you have the pedal length and pedal width. So the pedal length and the pedal width are vertically concatenated. So this one is on top or vertically on top of these ones. You can see it's pedal length, both of these one on top, and then pedal width is the same for both of the bottom ones. And then you do horizontal concatenation and join these two together. And you can see here the difference is the x-axis. One is sepal length, the other one is sepal width. So you say horizontal concatenation, you do sepal length first and then sepal width. Okay. Yeah, and just because I'm running out of time, I'm not going to cover this in too much details. As I said, and this is more just convenience. And if you find this syntax and not that easy to understand, you can just use vertical concatenation and horizontal concatenation will do exactly the same thing. And again, for the coursework, if you don't use any of the concatenation, just have every simple chart, which will be completely fine as well. Yeah. Okay, and so this is how you do using the vertical and horizontal concatenation. And this is actually what you do when you do the repeat. Okay, so this part actually will be very similar, except here you will say for the x-axis or the repeat columns, and then for the y-axis or the repeat the row. Okay, and then here you have this extra bit, and say in terms of repeat, you would say the column would be the sepal length and the sepal width. And so the column will be the x-axis, this one, column. So each one, these are the columns, the sepal length and sepal width. And the row will be the pedal length and the pedal width. So each this will be one row. So this will be pedal length and pedal width. Okay. Yeah, and finally, you have the facets of the chart. So this is now where you can just basically join. You can have. Okay, and the facets of the chart, and is you have multiple charts, but each of them only have a subset of the data. And so you can see here you have 3 species, and for the first one, it only has the first species, which is blue one, called a setosa or something, and the second one only contains the informational data for the second species, and the third chart only has a Virginica. Yeah, okay, and that's it. I'm gonna stop there, just because of time. I'm gonna use the last few minutes to talk about the Coursework 2 Okay. Let's go full screen. Oh. Okay, and so the coursework 2 will be due the first week we're coming back. So this is the last week for this term. So coursework due is the first week of next term. So you have a bit of time in between to work on that. Okay. Okay, I'm gonna skip this part. It's not about coursework 2. And 20% of total module, and it's due on the first week. Okay, and I need to update the slides here. That's the old one, which is not correct. And please follow the exact date on the submission page. Okay, and so the data comes from like a competition, and that's called the vast challenges. And that gives you data and some analysis tasks. And you also have some task and background information about the data set. But all these are made up, they are not real ones. I have to go back. Okay, and there's some information about the challenge itself. I'm going to skip. And again, so there's some background and about the data set. Again, I'm going to skip most of these. Okay, so what you have is you have a map, which is a natural reserve or national park. And in this park, you have these waterways and you have sensors as these different locations as shown on the map. So these sensors or the locations all have different names. And then for each sensor, and you have these kind of readings. And so it tells you for this one, for at Boonsbury, I think Boonsbury is this side here. You might not be able to see there. And on this date, the measurement for the water temperature is this much, 2 degrees. So on the January 1998, the water temperature measured here is 2 degrees. And here, okay, and then this is another measurement, same time, same place, and it's called dissolved oxygen. Its measurement is 9.1. So here, and the unit, so what the 9.1 represents is not critical, it's just the relative change is more important. Okay, so when you answer the questions, only use the data set provided. So the only data set you are given is the map and these numbers of different measurements. So that's all you need to use. And don't try to get and use, don't need to use any other data. Okay, I think, yeah. And the question itself is also has been updated. So you only need to answer the first 2 questions now, I believe. And if you go back here, so you would get this information on the module page. Save. Wow, why do? Okay. Yeah. So as I mentioned, now you only need to do 2 of the questions, basically only the first one. And so any trends or anomalies in the measurement readings, for example, and how does the water temperature change over time, or certain readings of chemicals change over time. And then the anomalies, and if something does not meet the overall trend. For example, maybe one site for some chemicals, the reading is way higher than all the other sites, and then becomes an anomaly. So that's the first part. And the second part will be describing any data quality issues. And so this is about, for example, is there any missing data or changing in the collection facility frequency? So missing data, I think you'll understand. In terms of frequency, maybe it was collecting once every hour, and then somehow it changed to once every day. So that's the changing in collection frequency. So you need to use visualizations to show these data issues. And you don't need to do anything about this one. You can forget about this. Okay. And yeah. So obviously you're going to be, instead of using bigger light, you're going to be using Altair to create the visualization. Okay. And yeah, so this is example using bigger light, so it's no longer relevant. Okay, and this is similar to what we have done so far. And you have these two questions you need to answer, and the trends and the anomalies in the data, and then any data quality or uncertainty issues. And then for each one, you need to say what the finding is, and possibly with a visualization. Okay, and make sure how that can be seen from the visualization itself. Sometimes maybe not very clear. I need to discuss how the visualization supported the finding, and this is come back to say the what, when, the how what are the data sets, what you need to find, and how are the designs to make it more obvious to see from the visualization. And then any advanced Vega Light visualization features used. Okay, and overall, and this pattern is very similar to the group work you did. And so you should be familiar with that. And if you have any questions, we can discuss that in the lab. Okay. So the marking scheme, 20%, and 6% will be about the finding, how insightful that is. I don't think I need to explain that anymore. And 6% is about effectiveness of the visual design. And you need to talk about the what and the why, and actually a little bit how as well. So why so you can talk about why do you choose certain type of charts, and why do you choose certain markers and channels, and why are they effective? Okay, and finally, the quality of the code itself. And instead of just the code itself, and do you use any advanced features in Altair? So for example, what we covered today is like a horizontal concatenation, different layers, or the repeated charts will be counted as advanced features. Okay, I really should have updated the slides. And here we're still talking about the HTML document, and what you need to submit again will be just a Jupyter notebook, and including both the validations and the text answering these questions. Okay, and that's it, slightly over. So as I mentioned, this week is the last week for this term. So we just done the lecture, and then in the lab, we're gonna do the group work demonstration, which we'll do a little bit later today. And then next week will be the first week of next term. And so that will be after the Christmas New Year break. So we have, okay. And again, we will not have any lectures or labs in that week, in week 12, which is the first week of next term. We will not have any lectures or labs. So if you have any questions, just email me, and I can try to answer or try to arrange a meeting to answer your questions. Okay, and yeah, and also, and very quickly, and after coursework 2 deadline, which is after week 12. So starting from week 13, and Xiao Hong will take over the lectures and labs for 6 weeks, and then I will come back after that. So Xiao Hong will talk about the image analysis using MATLAB or something similar there. So it's a different section of the module. That's from the week 13 onwards, which is the second week from the next term.